Hello, welcome back. We're at the point now where we have some things that we can use to solve problems using the C programming language, and it's a good idea to step back and think about an approach to solving problems. And that's what we'll do in this segment. So let's start off right away with a problem, and it's really a fairly simple problem. It comes as an English language specification to us of what we need the program to do. So we have a shopper who's going to buy 3 items in a store. We'll ask the user for the price of each item, and then output the total of the 3 items, calculate tax at a rate of 7%, output the amount of tax and the grand total including tax. Okay, so this problem is really not that complicated. You could easily do this on a piece of paper. And what we're going to learn in this segment is the approach to taking the English language problems apart so that when they do get complicated, we have some tools to work with the problems and we don't get everything all muddled up. Okay, so here's a diagram called an input process output diagram. And this is a more formal representation of the problem than the English language specification. So this is the first step in taking apart the problem and making sure that we understand what the program we're going to write is supposed to be doing. So I've copied the specification here on this slide, and we have a 3-column chart, and on the left column we're going to write the things that have to be input into the program. So if you read the specification, it says ask the user for the price of each item. So I like to make up variable names and put them under the input and output column. So these are the actual variable names that we'll use when we write the program that does this. So I have input 1 price, input 2, or item 1 price, item 2 price, item 3 price are going to be the things that are input into this program. And then the middle column is what do we do with the inputs, and the last column is what are we going to output. So we're going to output the total price, the tax, and the grand total. And the processing column is what I like to use to program from. So as I'm writing the code, I flip back and forth between this IPO diagram and the code, and I say, okay, well, I've done that one, now let's do the next one. And it's an easier way of dividing the problem into parts that you can code from, as opposed to coding from an informal English description of the problem. And remember that this one really isn't a good example for how this tool would be useful to take a complex problem apart. This example is good because it shows you what the mechanism is with a very simple example. Okay, the next thing that we need to do before we start writing the code, and that's important, before you start writing the code, you know exactly, if you put in these values, you know exactly what the expected values coming out should be. So again, we have the specification copied onto this page so that we can look at it. And the test data is the data that the user will input into the program. So for one run of this program, the user might enter 10.5, 4.25, and 6.1 as the 3 prices of the items. So if you know, given that input, what the expected output should be, then you understand the problem. And again, this one is a pretty simple one. So total price should be the sum of these 3 numbers, the 3 input numbers. The tax should be 7% of the total price, and the grand total should be the total price plus the tax. If you actually write down at least one test case, and in a more interesting problem, several test cases would be required to make sure that you really do understand what the specification is asking you to do. If you read an English description of something, it can be quite deceptive. You can look at it and say, yes, I do understand that, and then when you go to write the code is so formal that you find out, oh, I don't really know exactly what I was supposed to do with this one, and the code gets messier and messier. So this is kind of an intermediate step from the informal description a more formal description, and then the code is the most formal description of the problem that you're solving. Well, I think I just said most of this. When the specifications are complex, we're going to take the English description of what was written, and we're going to make an IPO, which is a more formal description. And then when you make the test case, you know exactly what the problem is asking, or you know how you're interpreting what the problem is asking. And then we're going to write the code from the IPO and from the test case, and not from the English description of the problem. Here's something new that we hadn't talked about up until now: comments in a program, and we'll write comments in this C program as we go to the development environment. Comments in your program are documentation of the program. They're not for the computer to read. They're for the humans who pick up a copy of your code and need to know who wrote it and what is it doing. And there's two types of comments. The syntax for the first type is a double slash. Anything on the remaining part of that line is not looked at by the compiler. So a double slash is usually called an end of line comment. Excuse me. And the next kind of a comment is a block comment, and it starts with a slash asterisk and ends with an asterisk slash. And that can be multiple lines of comments, and you can put anything in there that you want the next reader of your code to see, and the computer will not look at those either. There's a great deal of emphasis in some programming circles of how you should comment, what you should document in the actual code file, in the .c file. And what I like to do with beginning programmers is to tell them that we'll just let this evolve as we go along. It is an important skill to correctly comment the code, but at this point you don't really know what parts should be commented and what parts don't need to be commented. So we'll put comments in, but we won't pay too much attention to whether this is a good professional way of commenting the code or not. Let's go to the development environment now and start looking at how to write the code that would solve this particular problem with the three prices. Okay, here we are in the Visual C development environment, and we're going to work on the problem that we have specified and developed the IPO for. And let's go and start a file new project. It will be a Win32 console application, and I'll call it Three Prices. That's the name of the project. And then the Visual Studio will ask us for application settings, and the only important one here is that we want to start an empty project. And finish. Now we're going to add a source file, so right click on source files and say add a new item. It will be a C++ file, but we're going to make it a C file, and I'll call it prices.c, and that's the important part, .c. This would be a good place for you to get your development environment open and flip back and forth between the development environment and this presentation and program along with this. So here we have prices.c, an empty program, and we're going to start developing in here. So this is the includes. We're going to include the standard io.h so that we can do input and output, and we're going to include the standard lib so that we can do the system pause. Every C program has a main function, all lowercase, open brace, close brace, and we'll put in the system pause here so that it will stop and let us see what we've done on the console window. Well, it doesn't cost anything to compile this and make sure that we have a good starting place. Remember that if you want to do this quickly, compile, you can do it with F7. And if you get this one succeeded, then you haven't made any typing errors. If you get a one failed here, then you have to scroll up in this window and find the compile errors, double click on them, and start trying to figure out what the typing error was. Okay, so now we have a C program that compiles and it does nothing. Let's run that and make sure that it does run and does nothing. Press any key to continue. Okay. And now let's flip back and forth between the IPO that we're going to program from and the development environment. So what is the first thing that we have to do? We're going to declare some variables, and then we're going to ask the user for 3 prices. So in the development environment, let's declare the variables as doubles. Item 1 price, item 2 price, and item 3 price. And now we're going to ask the user for those amounts. So let's put a prompt first. This is an output statement. Printf, enter the first price. And we can go to a new line there if we want to. Close the double quotes. So there's the prompt, and now we're going to scan in. This is an input statement. The first price. So scanf, and our formatting string, %lf, which is what we learned in the previous segment, is for a double. And we're going to put an ampersand here before the variable name item 1 price. And what I encourage you to do, even though it's not part of the specification, to output the value that the user entered. You entered %.2lf \n. And this output statement is just to make us confident that these input-output statements are working, that we actually did receive the value from the user, and it is in the variable, item 1 price. Okay, so here's an output statement that includes the output of the value of a variable, and remember that the 0.2 is the places of accuracy past the decimal. LF indicates that this variable is going to be a double, and notice that we have an ampersand here before the name of the variable, and we don't have an ampersand here before the name of the variable. And I haven't explained why. We're just going to do that for now on our input and output statements. So F7 would compile this, and F5 would run it, enter the first price, put in anything you like, and the program will spit this answer back out with 2 places of accuracy. So we're confident now that we are asking the user for the value of the variables, and the user is entering the values and we're storing them into the variables. So let's do that twice more. Printf, enter the second price, and scan it in %lf, and don't put anything inside of those double quotes in the scanf except for the formatting string, And then let's go get the third one. Printf, enter the third price. And scan it in. Also remember that you can't force the user to enter 2 places past the decimal on an input. You can only specify that you want a double using the %lf. And now, why don't we just use some cut and paste here. Okay, so here's the first price, we scanned it in, then we echo it back. Here's the second price, we scan it in and echo it back. So this will be item 2 price, and this will be item 3 price as we echo them back. And now we should compile and run this. F7 and F5, just to make sure that we have the values that the user is entering. 34.78. Okay, so this seems to be working. The values are coming back to us, so we're confident that the values entered are in those variables. Now, let's flip back to our IPO and see what we have done so far. Ask the user for the 3 prices. We've done that, and we've scanned them into the 3 variables. And now the next thing we have to do is to total the 3 prices. So we have a variable here called total price, and that's where we're going to store the result of adding the 3 prices. So let's first of all go up here and declare a variable total price. And then we can say total price gets item 1 price plus item 2 price plus item 3 price. So we have done the calculation now of the total of the 3 prices. Let's flip back to the process diagram and see what we should do now. Calculate the tax, and then calculate the grand total. I wonder if we can do 2 at a time. Okay, let's declare another variable, tax, and another variable, grand total. You can make up as many of these variable names as you need. So now, total price, and we're going to calculate the tax. So tax gets the total price multiplied by 0.07, that would be 7%, and the grand total gets the total price plus the tax. So we've calculated the tax and calculated the grand total. We use these variable names. You should kind of notice that it's a little bit easier if we picked the variable names during the creation of this IPO diagram. And now output the results. So what do we want to output? The total price, the tax, and the grand total. Output statements are printf. Printf, how about the total price is % L, let's put 0.2 LF so that it doesn't put a whole pile of things after the decimal. and we'll put here total price, and another output statement, printf, the tax is %.2LF, and a carriage return, and the variable is tax, and the next output statement, printf, the grand total is %.2LF \n grand total. Notice that the difference between what you write inside of the double quotes is not the actual variable names. These are the variable names, and they have to be spelled, including the case of the letters, the same way all the time, including the same way you decided to spell them when you declared them. So this, in the declaration of the variable, we decide how the variable will be written, and we're going to use that the same way all the time. Okay, let's flip back to the IPO diagram, and it looks like we've done all of these things. Now, how do we know if it works? Well, I guess the first thing to do is to compile it. And we have 1 succeeded, 0 failed. It's unlikely that as a beginner you would type this much code without having a typing error of some kind. So look for the correct spelling of all of your variables and look for the double quotes. When you get one syntax error, it's very likely that you'll have several syntax errors, and these are called cascading errors. When the compiler finds one mistake, sometimes it it might as well just say, I'm confused now about everything. And you should look for the first error only. And if you fix that, you might have fixed all of the rest of the errors. So sometimes it's frustrating for students to make one typing error and get 6 syntax errors because of that one error. And it's not really 6 errors, it's one error that confused the compiler enough to think that there are 6 things wrong. So let's, in my case, I have now 0 errors. We can ignore these warnings. And let's see if it will run. And we'll put in some very simple data so that we can see instantly if this is doing some calculation that seems to make sense. So if we put 1.0, 1.0, and 1.0, I know that the total of that is going to be 3. And the tax on $3 is 21 cents, and the grand total is 321. So this seems to be working. Now what we want to do is to go back and use our test case that we created and make sure that our program is producing the expected results that we wrote down in the test case. So back in these PowerPoint slides, we made this test data 10.50, 4.25, 6.10, and we were expecting these results 2085, 146, and 2231. So let me see if I can remember all 3 of these, 10.5, 4.25, and 6.1. As I flip back to the development environment, and we'll run this using F5, 10.50, I knew this was going to happen, I can't remember the others, 4.25, 4.25, 6.10, So the total price is 20.85, the tax is 1.46, and the total 22.31. Let's see if that was the expected result. Well, good. It seems to be working. Okay, if you're wondering how I'm flipping back from one application to the other, this is a very useful thing to have in your list of skills in Windows. I hold the Alt key and I push the Tab key, so I can switch around between the applications that I have running. Right now I'm running three different programs here that are of interest to you. One is the program that we just wrote, and it has a symbol that looks like a DOS window, and then here's the PowerPoint slide that we were looking at, and here's the development environment. So every time you push Tab while holding the Alt key, you can switch to another of the applications that you have running. Okay, so let's make a little bit more room here so we can see if we can review. We declared the variables that we're going to use. We didn't do them all at once. We went back and declared more variables up at the top as we needed them. And then we have our input and output statements where we prompted the user for each price. Make sure that if you use cut and paste that you get all of these variables right. 3 variables, almost the same name, is error prone. Then we did the calculation steps. We found the total price by adding the 3 prices that were entered. We calculated the tax by multiplying the total price by 0.07. And then we calculated the grand total, which is the total price plus the tax. And then the final step where we output the results, the calculated values, the total price, the tax, and the grand total. Okay, we haven't put any comments in here yet, and let's just put a few end-of-line comments. Variable declarations. You can put whatever you want in these. The machine isn't looking at them. Get the data from the user. Calculate the results and output the results. Now, these comments, I probably wouldn't have made these comments in a professional piece of code, because anyone reading these C programs would already be able to tell by looking at the code that this is the output of the results. So for now, if you put in these comments, they're for you as a beginner to help separate the parts of your work and understand what's going on. If we put a block comment up here, a lot of people will recommend that you put a block comment at the top of your programs, and what you might want to do in here is to write the specification, or some programming shops will ask you to write some information about the program that you're writing. So who are you? When are you creating this? This is June 23rd, 2007, and the specification. So if you want to paste in the specification or what this program is doing so that the reader of your code could look at the specification and then compare that to the code, that's in some programming shops a useful thing. And it depends on why you're taking this course as to whether you're going to start doing these things now. So if you have an instructor who insists that you do these comments in a very specific way, then you do them that way. let's look at a few other things in here. The spacing horizontally is a question of style. For example, it's very common that you would put a space before and after each operator, but the C language doesn't require that. I find this line of code now difficult to read, and it's just kind of cramped. So I put one space before and after each operator. You can't put a space inside of your variable identifiers. Those have to be spelled with as one symbol. And we looked at the rules for making up variables in a previous segment. Vertical spacing, there are conventions for that as well, and probably a space before the main starts, a space, a blank line after the declaration of the variables, and a blank line that just kind of separates each of the parts of the program that you're writing. Okay, let's now go and review the review the concepts that we've covered in this segment. Okay, here's a summary of the concepts that we looked at in this segment. We took the particular skills that we've developed so far in the first segments for input, output, and arithmetic and assignment, and we looked at a problem that can be solved using a tool called an IPO, or an input process output diagram. The reason for having an IPO, an input process diagram, is so that you have a more formal description of the problem that you're going to code from, and I mean more formal than the English language description that these specifications always arrive to the programmers. And they're very vague, and you have to turn that into something that's very formal and very precise. So that's an intermediate step. At least one test case should be created that includes the expected results for some input data. If you don't have the ability to say, if I give the program this, I expect the program to give me back this, then you don't really have a firm understanding of what the code is going to do. And that's not a good place to start writing code if you don't know what it's really supposed to do exactly. So a test case with the expected results is a good way to convince yourself that you have the confidence that you're ready to actually write the formal code for that particular problem. And the last concept that we snuck into this segment is that the program should be documented with comments for the reader of the program to understand. This is an important part in our programming evolution. It's important for us to say just learning the syntax of the language isn't enough. You have to learn how to start taking problems apart to solve them using the language, and do it in an organized way, so that the product that you produce, the code that you produce, will appear professional and well thought out. Okay, at this point I'd invite you to send me comments by email on what you've done so far, and if you're stuck, and I also invite you to tell me where you are and why you're doing this class. It would be an interesting thing for me to learn. And if you're stuck on something, if you don't like something, tell me. That's very valuable as I create more of these, to know how I could make them better. So there's an email address. See you in the next segment.